Hello, Intro to Stats. How are you? Um, I'm going to start this by saying I am using a new tablet, and it's not super smooth in terms of the writing, so please bear with me as my handwriting probably is not going to be super good. Second thing is, this is really just going to be the same material that you read from the textbook, but I thought Chapter 5 is a little bit more challenging in that it might help to see it twice. So, if you read the book and you feel super good about it, you can just skip through this. But if you want a quick refresher, this is not going to be um, hopefully too long. So, strap in. All right, 5.1, two types of random variables. So, my first example is about coins, and it's probably the same one that's in the book. I actually didn't really um, look or notice. But let's consider what would happen if I take a coin, like a quarter, and I toss it in the air 3 times. Create the sample space for tossing. Why aren't you writing? Oh yeah. Create a sample space for tossing a fair coin 3 times. So what could happen? Well, I could get heads, 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 right? I could get 3 heads in a row. Is that the only thing that could happen? Of course not. I could get tails, tails, tails. But I don't just have to get heads or tails. There's a lot of other things I could have. So I'm going to write these out here. I could get heads, heads, tails, heads, tails, heads, tails, heads, heads. So that's all of the cases where there's only one tail. So third, second, first tail. Okay. I could get heads, tails, tails. Or I could get tails, heads, tails, or tails, tails, heads. All right, so that's the cases where there's one head, 2 tails. And actually, that's it. These are the only 8 things that could happen if I flip a fair coin 3 times. This, what we just created, is something called the sample space. We probably mentioned that back when we were doing probability, but it can't hurt to just mention it again. The sample space is all possible outcomes. All possible outcomes. Okay, so let's talk about random variables though, because that's actually what we're talking about. If we say let x be equal to the number of heads obtained, then we are making x something of a random variable. Well, what? Random variable. Okay, what are the possible values of x that we could have? The number of heads obtained. Well, I could have no heads, like in this case. I could have 1 head, like in this case. I could have 2 heads, or I could have 3 heads. If I'm flipping a fair coin 3 times, the most amount of heads I could have is 3. So these are all the possibilities here for this random variable of x. This is, oh, I did not mean to do that. This, okay, come on, is going to get us to create something called a probability distribution, which I also think we talked about briefly when we were talking about probability, but honestly, that was a long time ago, so we're going to just review it again. So a probability distribution is made up of 2 things. It is, okay, why is this so bad? Let me try this again. Okay, I'm so sorry, ladies. Let's do this. All right, probability distribution. Probability distribution is made up of the things that it could be. So x could be, we already said 0, x could be 1, x could be 2, or x could be 3. All of the things it could be. And, oh, this is bad. That's okay. The probability of any of those things happening. So let's consider. Here are all the possible outcomes. What is the probability that I get only, or actually, let's say 0 heads? Well, there's only one case here. Only one out of a total 1, 2, 3, 4, 5, 6, 7, 8. So the probability that x is equal to 0, that there are 0 heads here, is 1/8. Similarly, there was only one case where I got 3 heads, so that's also 1/8. And then if we go back up, we can count the number of times we get 1 head. That would be 1, 2, 3. So 3 out of 8. and the other one is also 3 out of 8, the cases where there's 2 heads. Notice if I add up all of these, 1 plus 3 plus 3 plus 1 is equal to 8 out of 8. That's really important. We're going to kind of come back to this, but just as a reminder, all of these things have to add up to 1. That was a bad marker to use. They have to add up to 1. And this is our probability distribution. Again, it gives us all of the possible outcomes and the probability of each outcome. So now let's answer a question. What's the probability that we get at least one head in the coin tosses? The probability that X, the number of heads we get, is at least 1, greater than or equal to 1. Now there's 2 ways we can do this. We can either add up the probability that X is equal to 1, the probability that X is equal to 2, and the probability that X is equal to 3. All right, so let's do that. Probability that X is equal to 1 was 3/8. X is equal to 2, 3/8. And X is equal to 3, 1/8. And we would get 3 plus 3 is 6 plus 1 is 7. Okay, that's one way to do this. But, oh, that was bad. But maybe you're sitting at home and you're like, I can see another way. If I want to, all right. If I want to find the probability that I get at least one head here, probability that X is greater than or equal to 1, I could also write this as 1 minus the probability that X is equal to 0. So getting at least one head, I'm going to go up for a second, getting at least one head was all of these, right? 1, 2, or 3. So if I want to find this probability, I can take everything but that one. So another way, again, to do this would be 1 minus the probability that X is equal to 0, or 1/8, which would give us the same answer as before, 7/8. All right, there's only a little bit more in this section, and it's mostly definitions. So let's talk about what a random variable is officially, because we kind of said this, but I didn't really give you a clear definition. So a random variable is a numeric variable that describes the outcome of some chance process. Now, often random variables are going to be capital letters. You'll see X, Y, and Z as the 3 most common to denote them. So if you ever see a capital variable, that's what we're talking about. Random variables have 2 different kinds. They have discrete and continuous. So a discrete random variable is a fixed set of outcomes, which I'll come back to in a moment. And a continuous random variable can take, any value in an interval. So I have this weird little picture here. I've got ugly feet and shoes. So this is talking about shoe size, which would be a discrete random variable. Why? Because shoe sizes come at integers, basically, right? You can have a size 6 shoe or a size 7. I mean, you could have a 6.5, but is there a 6.3 shoe? Oh, that's a tongue twister. Shoe size? No. Versus your foot size, if I were to measure my foot, it's not just going to be 21 centimeters. I don't know, 21 centimeters is probably too small. Whatever. A foot size can be measured pretty much any value from, let's say, 0 to 1 foot, right? It can be 11.1 inches or 11.2 inches, where a shoe size can only be certain values. So x is equal to 6, 6.5, 7, etc. But here, our random variable of foot size, well, it can really be any sort of centimeter measure on an interval. So let's say it's going to be something between, like 5 centimeters for a baby's foot to, I don't even know what, 18 centimeters? That's probably way too small. I don't even know. But any interval or any number in this interval, it is a continuous random variable. All right, I got one example for you. In 2010, there were 1,319 games played by the NHL. Imagine selecting one team from these games at random and then randomly selecting one of the two. Oh, okay, I'm sorry. I'm reading two things while I'm doing something. Let me try that again. Imagine selecting one of these games at random and then, of that game, randomly selecting one of the two teams. Define the random variable x to be the number of goals scored by a randomly selected team. The table below gives the probability distribution of x. A says, show that the probability distribution is legitimate, and B says, what is the probability that the number of goals scored is at least 6? My first question is not actually on here. Is this a discrete or a continuous random variable? Think for a moment and consider the answer. It is discrete. Why? Well, we can't have 1.2 goals. You either have one goal or you have two goals. You don't have 1.5. You don't have 6.1. So it's a discrete random variable. All right, A says show that this probability model is legitimate. There's two things we should look for. The first thing we should notice is that all of these are legit probabilities, which they are. Remember, a probability has to be between 0 and 1. So if I had a negative number or a number greater than 1, it probably wouldn't make sense. But then the more important thing that they want us to check is, do they add up to 1? So we technically would write this all probability of x equals 2, but I don't have enough room, so I am going to write it like this. And we would check this. We would take 0.061 plus 0.154 plus, and do all of them 0.001. And I'm going to spoil it, but yes, they are going to add up to 1. This is a legit probability model. Honestly, this would probably be something that is going to work out unless it's a multiple choice. That would be the time when maybe it's not a legitimate model. B then says, what is the probability that the number of goals scored by a randomly selected team in a randomly selected game is at least 6? The probability that x is at least 6, meaning what? How would we write this? Probability that is at least 6, greater than or equal to 6. So we're looking at the probability that x is 6 or 7 or 8 or 9. Hold on. All right, I quick paused it just to make this look a little nicer. So plus the probability that x equals 9, right? If we are looking to find randomly selected game, the number of goals is at least 6. We're looking for 6 or more. All right, so we're just going to take those probabilities. So 6, 7, 8, 9, these guys right here. Add them all up, so 0.041 plus 0.015 plus 0.004 and 0.001. When we add these all up, I actually don't have the answer right in front of me, so hold on. All right, when I added those all up, I got 0.061, or if we want to make this maybe a little bit more understandable, we're saying that there is about a 6% chance that a team will score at least 6 goals. Da da da. All right. I hope that helped. Otherwise, if it didn't, please reach out, ask questions. I would love to help. And this is your homework for section 5.1. Have a lovely rest of your day. Miss you all.